Hi everyone, myself Amalasmeena from RMD Engineering College, working as an assistant professor in ECE department. I welcome you all to the video lecture on digital principles and system design. In this presentation, we are going to see about delay flip-flop, which is also called as D flip-flop. We will see about their structure, how they are working, their characteristics, and where we can use them. Before get started, we should know about what is flip-flop, where we are actually using this in digital circuit. Flip-flop is a memory element which acts as a building block of any sequential circuit. It can be built with the help of latch and control input. Then, what is this control input? What is the trigger? Control input is nothing but a clock which plays the main role in flip-flop. Actually, the entire operation of flip-flop depends upon this clock. We can also use flip-flop for storage purpose, which is used to store just one bit information. Then, how many types of flip-flops are available? We are having 4 types of flip-flop. They are SR flip-flop, D flip-flop, JK flip-flop, and T flip-flop. Among this, we will see about D flip-flop in this presentation. Very first, we should know about why we are going for this D flip-flop rather than our SR flip-flop. In SR flip-flop, when both the inputs are high, I mean when S equal to 1 and R equal to 1, we will have invalid condition, or we can also call them as unused condition or forbidden condition also. Then how to avoid this condition? To overcome this condition, my input should not be equal at the same time. For this reason only, I am going for D flip-flop. This is a logic diagram of D flip-flop. Here we can clearly understand that D input is directly given to S input and D complement is given to R input. So only two conditions will be available here, either S equal to 0 and R equal to 1 or S equal to 1 and R equal to 0. From this we can avoid the unused condition which is happening in SR flip-flop. And here we are having two outputs, one is normal output and another one is inverted output. Now let's see about working of this D flip-flop. This table shows the functionality of the D flip-flop. When clock is low, the D flip-flop won't take any inputs. So the output will be the previous value. This state can be called as memory state or previous state. For all the remaining analysis, we are going to consider our clock is high. Now D input is given as 0. It means S equal to 0 and R equal to 1 because of this complement function. For this condition, the output will be 0. The state is called as reset state. Similarly, when D equal to 1, our S value will be 1 and R value will be 0. At the time, flip-flop output will become 1. It shows that at this state, flip-flop will be the set state. That's all about the functionality of D flip-flop. Now, let's see about the characteristics table of D flip-flop, which has 3 sections. Those are present state, flip-flop inputs, and next state. Actually, this table is constructed from the function table, which we have seen earlier. Here we are having 2 inputs, Qn and D. So we will be having just 4 input combinations. Those are 0, 0, 0, 1, 1, 0, and 1, 1. Now, let's try to find out the values for Qn plus 1 by using this truth table. When D is 0, Qn plus 1 is 0. When D is 1, it means Qn plus 1 is simply 1 based on the truth table. Again, when D is 0, Qn plus 1 is 0 and D is 1, Qn plus 1 is 1. From this characteristics table, we can notice one thing. Our next stage, Qn plus 1, which is equal to D, that is nothing but our flip-flop input. But we can give a name for this equation as characteristic equation. Now, it's time to move into excitation table. Here we are having 2 inputs, Qn and Qn plus 1, and the output is D. With the help of this characteristic table, we can directly write the value for the output. Because we know that in D flip-flop, the next state which is equal to the flip-flop output, right? So here, my input Qn plus 1, which is equal to the output D. Finally, we are going to see how to draw the state diagram for the D flip-flop. Basically, state diagram is a graphical representation of the state table. Here, we have considered that as an excitation table. Take a look of this diagram. Here, orange color circles represent the states and the transition between those states is represented with the help of black color lines. And finally, these lines are labeled by the flip-flop inputs. Basically, it's easy to understand the state diagram. The logic is when the present state and next state are equal, flip-flop will remain in the same state, or else the transition will be happening. That's it. Coming to application, to transfer the data from input to output, we can use D flip-flop since this is a transparent latch. Other than data communication, it can be used in registers, counters, event detectors, and frequency divider circuits, etc. To conclude, D flip-flop is the efficient and widely used flip-flop among all the flip-flops because of this simplicity and functionality. That's all about this presentation. I hope this video lecture will be helpful for you all. Thank you.